Yeah.
All right. Good afternoon. My name is Jeremiah Maxfield, and today I will be presenting on conquering the digital divide in South Dakota. Before we get started, we should probably talk about what is the digital divide. When we say the digital divide, this is referring to spaces across the United States and the world of areas that don't have access to reliable high-speed internet. Now, the term of reliable high-speed internet has changed throughout the years. In our current standing in South Dakota, that is referred to as 100 megabyte download speed and 20 megabyte upload speed. So now that we know a little bit about the digital divide, let's kind of dig into it. So for this analysis that we're conducting, we're looking at areas for conquering the digital divide, but we don't want to just aimlessly do it with anywhere. We want to find the best areas with the most suitable building based off population and population density, and also the areas that we can have essentially the most bang for our buck. So to do this, we're going to build a site suitability analysis. But the first step is we have to obtain and create all of the data that will be used in this analysis. The first step this year with the changes on the FCC, they're moving to a location-based hexagonal pattern. And this is going to differ from what they have done in the past. Previously, they used census blocks. This caused a huge issue where we would see areas that are essentially misrepresented and coverages were a lot more inflated. If one provider owned or had one hookup, and then they could claim the entire census block. So this really skewed data and made it not really reliable. So with the new location-based data, we should be able to get a much more pinpoint accurate data. So the key is this hexagonal pattern. It is an open source code for the Uber H3 hexate pattern. But working in state government, I am not allowed to use open source coding in any of my work because of security reasons. But luckily for me, I was able to actually gain the national hex 8, hex 7, and hex 6 patterns from Esri from their broadband team. So by pulling this in to my ArcGIS Pro project, I was then able to run a select features and base every hexagon that was linked to South Dakota. I was able to copy that to a new feature class and only pull the data set for South Dakota. So once we get that all pulled in, we only are looking at South Dakota. Oh no, I think my story map is skizzing out on me a little bit. As we can see here, sorry about that. This is what our hexagons look like as we're going through. We can click on them. Every hexagon has an individual, essentially address, which is what we're going to use as the basis to build all of our data. So if we open up the attribute table for our state hexagon pattern, we're going to see a field known as the H3 index. This is essentially the address for every hexagon that is unique to everyone. These will be very useful as we go on. Once we can see that, the next step is going to be getting our data that we need from the FCC. Every biannually, the FCC releases data of broadband technologies, mobile availability data technologies, and summary types. For this one, we are going to pull in the cable and fiber technologies here, as you will see, and these will download as a CSV file. If anybody would like, you can click this link and it'll take you right to there. You can do it by state as well. So what I did is I downloaded both of these data sets that I needed to, and I imported them into my ArcGIS Pro project. And if we open up the data table, we're going to see a lot more information than we did in the state layer. We're going to see technology, what brand it is, what its FIPS code is, what the max advertised download and upload speed is. And the big one that we're going to see is going to be this H3 Resolution 8 ID. Hopefully that looks familiar because that is going to match up exactly with the H3 index from the state layer. So to essentially colorize and begin building our data of our coverage layer, what we're going to do is I ran a join based off those two features. And what this was able to do after I ran the join is we can start building our data. The key is I believe in the state, there was 271,000 hexagons. And the key for this is only finding the ones that are going to pertain or contain your data. I think my map is running very, very slow now. But the key is, so you want to really go through and modify your symbology and select everything that has a null value. This to clean it up and make it a little bit better. I do apologize for this. I'm not sure exactly why it's doing that. I'm just going to go ahead and refresh this page real quick. This is the fun part. Okay, there we go. Now it's working, so I won't mess it up again. All right. So as we can see, once I did this for both classes, for cable and fiber. And then what I actually did is I actually joined them into one feature class, kind of combine them as just a cable fiber coverage area. And everywhere that is colored, we will see has some type of hookups. And we can bring in and zoom in, and we'll start to see, how granular this really can get. And then there was one more layer that we decided that we were asked to use. This is from the Governor's Office of Economic Development. We named it a provider submitted fiber expansion. So anything that the providers have completed and built after the FCC needed the results for the Form 477, we went ahead and added this in there in a separate layer. That way we could have the most up-to-date areas that had fiber, even more so fresher and better data than what the FCC was provided with. And we added both of these in on top of each other. And then after we did that, I ran an erase feature tool. And what I did is I erased based off both of the provider submitted expansion layer and the cable fiber coverage layer. And what this does is this leaves us with a new layer that is essentially a zero coverage layer throughout the entire state, which is really beneficial. If you look at this compared to our previous year's models, you're going to see a lot more holes and gaps in coverage just because of the new location-based modeling. So this really opened up a lot of eyes, and I think a lot of people were surprised on that. So now that we have our zero coverage layer, this is what will become our suitability analysis layer. It's going to be known as a target layer inside the suitability analysis tool. So what we did to build the suitability analysis tool, this is an actual tool inside the business analyst toolbox. And once we create that, we targeted our zero coverage layer as the target layer. And then inside of there's pre-built criteria that we can choose. So what we did is we decided to choose 3 criteria that made the most sense for me, based off what I wanted to get for my target audience. The first criteria was the 2020 population. As you can see here, you're able to modify every aspect of this. I set for this one, after running several different test runs on it, I moved the weight to 29.81%. And then we also want to have a positive influence. So what the positive influence is meaning is the higher the population, the higher the Z-score value will be. And so it's going to really help us with that. And then our next criteria that we're using is going to be the population density. I think these two really need to go hand in hand. We're going to find out areas that are, more densely populated in smaller blocks, especially as we get out on the west side of South Dakota, just because of geographical restrictions. So for this one, I set the weight to 40%, also with a positive influence. So again, the higher the population density, the higher the Z-score value will be. And then our third and final criteria that I used is from the ACS, which is the American Community Surveys. And what we're looking at is from 2021, we want households with internet broadband in their 5-year plan. So what we did for this is we set the weight to 30.18%. And then a change that we did that should be noted is based off the influence. I wanted to use an inverse influence. So this is going to just be the opposite of the positive. So the lower the number is, the higher the Z-score will be. Because we don't want areas that have, according to this, higher broadband internet people and households. We want to find the households that have the least amount of internet in them. So then based off those three, we were able to run this. And I will tell you, it took me about 5 or 6 different runs of really trying to fine tune data to really get what we were wanting. So based off this, we were left with 155 locations based off our criteria that we were able to use to meet our goals. As we can come in here, I know they're quite hard to see, but being as they are only about a quarter mile in area, we can see that the largest areas that we're going to really have these biggest populations is going to be in the western side of South Dakota. So the fun part with South Dakota, there's less than 1 million people here in the entire state. So we can use this data to really help close our digital divide. Based off the FCC data, we are looking at approximately 30.6 thousand unserved broadband locations across the state as a whole. And by using these capabilities in this next year for grant round applications, we are closing that gap to under 10,000. And that is in completion, I believe, by first quarter of 2024 is what we're looking at. And so we can even zoom in to here, we can see individual hexagons, and we can actually pull up the results of the suitability analysis. We will have full access. We can get even more in depth with it in ArcGIS Pro, but this is just in a quick web map that I did up. We can still see the join. We can see what the parent ID, what the H3 index is for that. But then we can also get down all the way into the suitability analysis. We can see what our population is. We can see how many people don't have internet in their house. And then we can also see our Z-score totals for everything. And I thought this was really cool. And when you run the suitability analysis tool, it's creating this just as part of the tool. So I thought that was really awesome. It gave a lot of cool results, and you can tweak these tools for anything if there was different types of aspects. I think one thing is that I should note is when we were doing this, when I was initially doing it, I didn't have to set I was really tweaking with the parameters. The big one being the population. In South Dakota, we're extremely rural. There's only one city with over 100,000 people. And what we see is individual farm sites that have, 10 to 20 people living on them. And in the initial analysis, that was pinging as a suitable site. But when you really got in to look at it and kind of dug deeper into the census level, it wasn't. So what we ended up doing is we upped the minimum threshold for the population. So if the population in the area did not have at least a minimum of 50, it would completely rule it out. So I feel like that is a very important thing with some of this data, is you really have to do several test runs with it. And then based off the results that we were able to gain from this, for this year, for the 2023 grant rounds, we were actually using this analysis to help develop target areas inside the state for providers to try to go with fiber and cable expansion for grant awards. And we will actually be coming out and doing a public news conference, I believe, on May 4th, showing all of these results and also unveiling new fun broadband stuff that I was able to build because of this course. But this was the direct correlation of how we were able to target those areas for the most suitable and help drop in 1 year from 30,000 to under 10,000 people by just using this analysis and finding the best areas that we should target. Is there any questions for me at this time?